Hello guys, welcome again with you now, Abdulrahman Ahmad, your math teacher. We're gonna talk today about something important, very important, which is helping us in our life every day and used a lot in many fields such as artificial intelligence and deep learning and robotics, stock market also, and many other fields. Okay, we use probability to make decisions. So our session today is about probability, and we are gonna learn about how to do math with things that only sometimes happen. They might be likely or unlikely. We are gonna learn about probability. So the question now is, what is probability? Okay, have your time, try to think. Usually in math we deal with things that always happen the same way. We are certain about the results. Okay, if you have this question 1 plus 1, the answer would be 2. So we are dealing with a fact here. Always you know the answer. Okay, this answer will be always the same, and we're certain about that. But in the real world, things aren't always so predictable. Take a coin toss for example. We can't predict whether if it would be heads or tails. It's unpredictable or random. Also if you toss a dice. And that's why some people will flip the coin to help decide which two things to do.
That's an excellent argument. Allow me to deliberate. Guilty.
There are two approaches to study probability. First one, experimental. Second one, theoretical. Let's start with the first one, experimental probability. Tossing a coin is an example for experimental probability. When a coin is tossed, there are two possible outcomes. First one, heads or tails. You will get heads or tails if you tossed a coin, like that. Tails, the side that has a text, and head, the side which has a photo. Notice that we can express the probability by percentage. It means we can write the probability of appearance of a head equal 50%. Okay, throwing a dice. Another example for experimental probability. There are many examples for experimental probability.
Is that it's certain that one of those 6 sides will land facing upwards, which is a probability of 1 or 100%. But since only one side can face upwards for a given roll, we have to divide up that value among all the possibilities. In the case of a coin toss, since there were only 2 possibilities, we had to divide the probability by 2. 1 divided by 2 is 1/2, which is the decimal 0.5 or 50%. But with the die, we need to divide the probability up evenly between 6 possibilities. 1 divided by 6 is 1/6, which is equivalent to 0.167 or 16.7%. So that would be right here on our probability line. That means it isn't likely that I would roll a 3, for instance, but it's just as likely as rolling any other number.
In general, experimental probability equals number of trials in which the outcomes occurs over total number of trials. Second, theoretical probability. We have here some definitions. First one, random experiment. It is an experiment in which we can specify all its possible outcomes before carrying it out, but we cannot determine certainly which of them will occur. Sample space. It is a set of all possible outcomes of a random experiment, and it is denoted by S. For example, when we toss a piece of coin once, then the sample space is S equals H and T. H stands for heads and T stands for tails. When we roll a fair die once, observing the apparent number on the upper face, then the sample space is S equal 1 or 2 or 3 or 4 or 5 or 6. Event is a subset of a sample space. We have here example. If A, the event of appearance of an odd number when rolling a fair dice once and observing the apparent number on the upper face, then A could be 1 and 3 and 5. All the odd numbers in the sample space. Generally, the probability of any event occurrence A, the subset of S, is denoted by P of A, and it is given by using the relation P of A equals, in the numerator we will put the number of elements of the event. In the denominator we will put the number of elements of sample space. So, number of elements of the event A over the number of the sample space equal the probability of any event. Now you should know that the probability of any event lies between 0 and 1, not less than 0 or bigger than 1, and we are gonna make this clearly on the probability line.
It's a number line that goes from 0 to 1. The probability of 0 means that an event cannot happen. It's impossible. And a probability of 1 means that an event is definitely going to happen. It's certain. That's why the probability line only goes from 0 to 1. An event can't be less likely than impossible, and it can't be more likely than certain. A probability of 1/2, like with our coin toss, means that an event is just as likely to happen as it is to not happen. A probability less than 1/2 means that an event is unlikely, and a probability greater than 1/2 means that an event is likely. Oh, and in addition to fractions, it's also common to write probabilities as decimals or percentages, since you can easily convert between those three. A probability of 0 is the same as a 0% chance of something happening. A probability of 1/2 is the same as a 50% chance of something happening. And a probability of 1 is the same as a 100% chance of something happening.
We have here some remarks. The probability of the impossible event equals 0, and the probability of the certain event equal 1. Practice to deeply understand. Okay, let's take these examples. Complete. The probability of the impossible event equal, yes, bravo, 0. Okay, the next question. The probability of the certain event equal, yes, take your time, bravo, 1. Okay, the third one. If the probability of occurring an event is 5/8, then the probability of not occurring of the same event equal, okay, here it is. The probability of occurring an event is 5/8. Plus what to get the certain event, which is 1, as bravo, 3/8. So the probability of occurring of an event plus the probability of not occurring of the same event equals 1. So our answer here will be 3/8. Bravo. Okay, the next question. As flipping a fair coin once, the probability of appearing a head is half. Bravo. A regular die is rolled once. The probability of getting a number less than 3 is Okay, bravo. 2/6. Question number 6. At throwing a fair die once, the probability of appearance of prime number on the upper face is, when with throwing a fair die once, the probability of appearance of a prime number here. Prime numbers are 2 and 3 and 5. We have the sample space for this experiment 1 and 2 and 3 and 4 and 5 and 6. So the number of our event is 3/6, which is equal 1/2. Bravo. Thank you guys. Here is your homework. Solve the math booklet pages 41 and 42. Thank you.